Well, this video is just a recap of some information that you learned back in Algebra 1 having to do with x and y intercepts. So first of all, we just want to fill in the blanks here, and of course you can read all of the information that the x and y intercept is just the point where a graph crosses either the x-axis or the y-axis. So the x-intercept in this case is -3, and the y-intercept is 4. So an x-intercept is also known, and this is just an x-intercept, is also known as a zero, a root, or a solution. All right, and so when we find the intercepts, because we know that y equals 0 on the x-axis, that's what we have to do to solve for x. Because if you think about the x-axis here, y equals 0 all the way along there. So if we want to find this point, then we just set y equal to 0. Same with trying to find the y-intercept. We set x equal to 0 because x equals 0 all along the y-axis. All right, so let's do that for this example, and then I'll work the first two problems, and then you have the back to do. Okay, so as we said earlier, in order to find the x-intercept, we set y equal to 0. So recognize y is right here. So I've just rewritten this equation, and instead of y, I've written 0 because we know that at the x-intercept, y equals 0. All right, and then for the y-intercept, we've rewritten the equation, and instead of putting x, we've put 0. And so now we can solve both of these equations. So when we do the first one, we'll just, I'm going to add 2x to both sides because I'm trying to isolate the x. So I end up with 2x equals 5. Now I'm just going to divide by 2 on both sides, so I get x equals 5/2. Now I can change that to a mixed number and say x equals 2 1/2. All right, so for the y-intercept, we're just going to do the math. So -2 times 0 is 0 plus 5, and that's going to equal y. So therefore, y equals 5. So now these are two different points because remember on the y-intercept x equals 0. So my point here is going to be 0, 5 for my y-intercept, and my x-intercept is going to be 2 1/2, 0, because the y was set to equal 0 on that particular point. So on problem number 1, we have this work done, and you'll notice that again we set the y equal to 0 to solve for the x-intercept, and we set x equal to 0 to solve for the y-intercept. Now these are the points associated with the intercept. The x-intercept is 1/5, the y-intercept is -1, and these points will be what we plot in order to set those two intercepts. Once we plot them, then we can draw the line. All right, to make it easier for me to graph these points, I've indicated that the 1 is 5 units away from 0. So 1/5, 2/5, 3/5, 4/5, 5/5. And I've done that all the way along each one of the axes so that it's easier to graph the 1/5 on the x-axis. So now that I've done that, I can plot the 1/5 on the x-axis right there. And pretty close. All right, and then the y-intercept is -1. So on the y-axis, I'm going to put a point at -1. And now I just draw the line to connect the two. And there's my line. So for problem number 2, here's the work. Again, we have the x-intercept is solved by setting y equal to 0, and we solve. Now notice down here we needed to isolate x. It had -6/5 times x, And so in order to get rid of the negative 6/5, we multiplied by its reciprocal, negative 5/6, because that allows us to divide the 5's out and divide the 6's out. And a negative times a negative gives us a positive, so we got a positive x on that side. We had to do the same thing to the other side, so we multiplied the negative 2 times negative 5/6. And here I indicated that the 6 turns into 3 times 2, allowing us to divide out the 2's, leaving us negative 5 times negative 1 in the numerator to give us 5, and it just left us 3 in the denominator. Okay, so again I put some markings on my grid because I need to graph 2/3. And so if I skip a couple of lines so that I'm identifying thirds, it makes it a little easier. So I have 1/3, 2/3, and then 1. And then 1/3, 2/3, and then 2, and so forth. So I had to do that to the entire thing so that it would work out appropriately. All right, so my x-intercept is 1 2/3, so I'm going to go to 1 2/3 and place a dot. And that's not quite on there. Well, that's good enough. It's hard to see that. And then y-intercept is at 2, so we'll put our dot there. And then we're going to draw our line connecting those two. And there is our graph. So now you have enough examples to work the back of the sheet and be familiar with intercepts.